So at this point, I would like to hand it over to Uriah and Joe. Again, they're from Nlign Analytics. They're going to be giving that presentation on the digital thread for the material review board. Uriah, are you ready?
Yes, I am. Can you hear me?
I sure can, and we can see you both too. Thank you, and take it away.
All right. One second here. Okay, so welcome to the digital thread for Material Review Board. I am Uriah Liggett of Nlign Analytics, and my background is in software engineering with a particular focus on aerospace applications, where Joe Kesler, who is the co-author, his background is in software engineering with a particular focus on algorithm development, and he is also of Nlign Analytics. So today I will be discussing the digital thread, some of the end goals, the life cycle, some of the challenges that are presented with the MRB process, which is the Material Review Board, and how the digital thread provides solutions for those problems, as well as enabling a wide variety of additional analysis. We'll also touch a little bit on how the digital thread transitions from manufacturing to sustainment, and we'll discuss the current state of the digital thread today. So the digital thread is, for the purposes of this presentation at least, is a digital record of all of the important events that have occurred throughout design, manufacturing, sustainment, and removal of a product. So for design, we're primarily interested in the as designed state. So that's going to be the 3D CAD models, the part materials, design requirements, everything of that nature. For the as built state, of course, what you build is never exactly as you designed it. There's always going to be small differences. So the digital thread is going to be a system that collects all of those small differences so that you're able to accurately capture the as-built state as well as the as-designed state. So that's going to be all of the discrepancies that resulted from the inspections, your repairs and modifications, as well as the unique serialization that you applied to the part that you manufactured. And that will transition to the as-maintained state. So all of the usage information of your product, the component installation history. So if this is a component that can move, we're talking aerospace primarily here. So if you have a nacelle or a wing that can move from one aircraft to the next, then you want to have all of that history, as well as all of the discrepancies, repairs, and things throughout the sustainment or the as-maintained state of that part, all collected into a same database to provide a digital thread of that particular part. So some of the manufacturing end goals are going to be achieving a higher production rate, reducing manufacturing costs, reducing manufacturing time, improving manufacturing quality, as well as improving the product value, because once you have all of this detailed information that the digital thread provides, then that product is more valuable to your customer as well. And lastly, everything that you have learned throughout the digital thread process, since you can have this information in a state that is easy to do analysis on, can better inform your new product design so that the next product you develop is better than the previous. The sustainment end goals are typically increased aircraft availability, reduce costs, reduce risk, and increase lifetime of that product. So the digital thread life cycle, generally it begins with design. All of that information we discussed goes into the digital thread. It continues into manufacturing, over into sustainment, and then even it's not just manufacturing information, it's also sustainment information that feeds back into that design. However, at each point, especially the sustainment and the manufacturing points, there are suppliers. So suppliers that are going to be providing major components of the product that you're manufacturing, or suppliers that are providing materials. So it's important that they are utilizing a digital thread solution as well, because what the suppliers manufacture isn't going to be exactly as they designed it as well. So it's important to get that information from them, feed it into the overall digital thread so that you have a more complete picture. So the MRB process that we are discussing in this presentation is the process of documenting a difference from the as designed state for a part. So typically you're going to call these discrepancies. So you document a discrepancy, and there needs to be some sort of way of resolving it. So if it's not outside of the allowable limits, then generally there is a standard repair that you can apply. And when I say discrepancy, I'm referring to things such as out of tolerance values for fastener, or maybe there's a step condition on a composite part, things of that nature. So if the discrepancy is outside of allowable limits, then a disposition needs to be developed in order to account for it. So the standard process is to search for precedents to see if there is already a disposition that you can reuse. And if not, then a new disposition has to be created, which is typically a very time-consuming, expensive process, because it requires often custom analysis and engaging multiple engineering teams in order to come up with a solution or disposition to solve that discrepancy. So some of the challenges with this process, often your part numbers are going to be incorrect, especially if you're working with a type of environment where your part numbers are constantly rolling, because you're at the start of your manufacturing process and you're making modifications to that design. So it can often be difficult for inspectors to get the correct part numbers when they are documenting a MRB. And unfortunately, part number is one of the most important pieces of information that's necessary in order to determine what a correct disposition should be. So the location can be very important depending upon what the actual part is. And often the means that inspectors have for specifying the location result in very inaccurate locations. So often it will be the photograph of the part that can key the engineer on where it actually is, or they have to actually go down and see it to have a good idea of where that damage is. And that may help them for solving that one MRB, but it does not help when you're looking to do general analysis in the future. So missing data, unstructured data, these are all things that make the MRB process much more, take much longer than it typically could. So the digital thread seeks to solve all of these problems by utilizing the information that we had discussed before. So as far as the incorrect part numbers, with the digital thread solution, you can pull the correct part numbers from your PLM system and your ERP system for the actual part that is being manufactured by pulling them directly from the three-dimensional CAD model. So inaccurate discrepancy locations, those locations can also be pulled directly from the model-based definition or the three-dimensional CAD model for that part. Missing or incorrect data, your digital thread system should have rules to enforce all of your data validity requirements, as well as structuring the data in a way that's going to make it very good for future searching and analysis. So part numbers. If you have access to the MRBs, then you can pull them directly from the part number, as I had mentioned before, and this can be done for on a serialized part by serialized part version. So even if that part number has road with a robust digital thread solution that is hooked into your PLM and ERP systems, it will always have the correct part number for the actual aircraft that is being manufactured. So estimating locations, it's not viable to guesstimate on where the location is. It's important to actually list it as exactly as possible. So if it's a point location, then you can interact directly with your model-based definition of that part and specify by just clicking on the mouse or some other mechanism of exactly where that part is. If it is an area-based damage, then you can still draw that area onto the actual three-dimensional CAD model in order to get very accurate location information for where that damage is. In addition to this, you can utilize the current methods of taking photographs, doing measurements, things like that, to help make that information more robust. So missing or incorrect data, if you have missing or incorrect data, then that data cannot be used without making a wide variety of assumptions, which can make it essentially useless. It can also introduce data inconsistencies, and it can cause your trends, if you want to do trend analysis, to be very incomplete. So the digital thread solution to this, for systems that implement a digital thread, is to have automated enforcement of data completeness, so that you can ensure before the record can be saved, you can ensure that all of the required fields are present and that there are no inconsistencies in the data. So the current process for writing MRBs generally results in long free-form text fields that are, they're hard to search, and they often summarize information where there may be a discrepancy that impacts 5 or 6 different fastener holes, and it'll be written up as all within a single record, where it will say, okay, there are 5 fasteners that are sunk too deep, and they range from 5 thou to 25 thou out of tolerance. So that may help for that one MRB, but that does not help when you're trying to find when you're trying to use that for analysis. So a good digital thread solution should not summarize that information. It should have each discrepancy as a separate record with its own location, distinct measurements, so on and so forth. So what can you expect to achieve once you implement a modern digital thread solution within MRB? Well, a reduction in inspection time. So the DoD estimates that their inspectors take 50% of their time just filling out documentation. So that's not performing inspections, that's just filling out paperwork. Whereas utilizing a digital thread system allows you to significantly reduce that time by utilizing 3D models to pull the correct part number, so it eliminates a large amount of searching, eliminating double data entry, being able to capture photos and videos directly, complete digital input, and fewer MRB rejections due to incorrect or incomplete data. You can also expect a reduction in engineering time. So being able to quickly determine where the problem exists and determine whether there is a previous disposition that can be reused instead of redoing that expensive analysis over again. So a joint project between AFRL, Northrop Grumman, and Nlign Analytics estimated a 33% savings in MRB labor hours in 2016. So it's important that a digital thread solution, as I had mentioned, integrates in with your PLM, MES, and ERP systems as much as possible, because it is a heterogeneous environment. So, and all of these types of systems store different pieces of information that are important for the digital thread. So what are some of the qualities of a digital thread analysis system? We've already touched upon most of these, such as accurate discrepancy locations, real-time data validation, actual numeric values for the measurements, being able to consolidate all of the information from manufacturing and sustainment into a single database, as well as having streamlined access to the current state of the structure. So that will enable you to determine, precise locations for damage that occurs repeatedly, so you can detect for trends and identify whether there is a manufacturing problem that's causing an increase of MRBs in a particular area, as well as identifying easier whether a part redesign needs to occur, as well as heat maps and things of past manufacturing discrepancies. So there are also benefits to sustainment. So with sustainment, it's going to provide knowledge of that as-built state. So within sustainment, they're able to reduce the assumed risk, having that additional information, which is going to increase the lifespan of the product and reduce the sustainment costs. So the current state of digital threat within aerospace, currently, digital threat solutions for MRB and for just aerospace in general are currently in use by many different market segments. The Nlign Analytics platform is used by major commercial aircraft manufacturers, major defense aircraft manufacturers, aerospace supply chain providers, defense individual aircraft tracking and MRO programs, as well as defense structural integrity programs. So it's there today, and it is currently being utilized. So in conclusion,
I'd just like to let you know that you're in your 5-minute window for your question.
Okay, thank you. So in conclusion, the digital, we've discussed the digital thread, some of the MRB challenges, the solutions that it provides, some of the analysis and transition to sustainment, and the current state of the digital thread. And now we are in question and answer. Thank you.
I see him typing. Okay, so the question that we have in the chat is, what PLM MESS platform has this solution been integrated in or integrated to in order to support digital MRB?
So the Nlign Analytics platform has, if you're referring to it specifically, has integrations with the Teamcenter PLM system, as well as the Aris Innovator PLM system. And typically with MES systems, we work directly with the manufacturers to provide custom solutions for them.
Okay, and Drew, how much time do we have left? I know we're cutting it pretty close.
We still have a couple minutes if you want to go ahead and answer Dave's question.
That was Dave's question.
No, it wasn't. That was Ms. Crow's question. David's question was, I think this is a great subject. Of course, the digital twin concept goes past MBD. Are you working on any other areas like design or manufacturing?
So as far as the digital twin, we focus primarily on the digital thread, which would be the collection of the information for that product, where the digital thread twin would be more on almost a digital virtual copy of that product that you're manufacturing. So as far as how we relate to the design, what we try to do is make all of that information available to the engineers that are doing the design, whether it was information collected in manufacturing or whether it was information collected in sustainment, so that they can see whether maybe there is a part that results in more issues than not, or it looks as if it may cause issues in the future, using some of the prognostics capabilities that are available within a digital twin, digital thread solution, and give that information to the designers so that they can then create a better design.
I will add on to that from the kind of manufacturing standpoint. We have applications where, in addition to bringing in discrepancies and repairs to assist MRB, we have people bring in other process information, say tooling information, information from, for composite applications, autoclave, AFP, and so on, and integrating all of that into the same system. So you do have kind of a complete digital record of and everything that occurred during the manufacturing of that structure.
Great. Okay. Drew, is there any more time? I think that's we're coming to the last couple minutes here.
Let's do the final question that we got. Are there any standards you would recommend to connect sustainment to operations?
Sustainment to operations. Standards in terms of data standards, maybe, or product standards. So so the Nlign Analytics product tries to, be a solution for all of those environments. So if you're looking for a system standard, then I would have to recommend it. As far as data standards, it would depend upon what type of data you're referring to, whether it's CAD or or meta information or whatever it may be. But yeah, I would need to work with you a little bit more in detail to understand exactly what type of information you're wanting to exchange there.
In general, does Nlign take the stance internal to their system solution to communicate with proprietary information, or do they support data exchange with industry data standards?
So Nlign supports data exchange with industry data standards. So the product itself supports open standards such as STEP, IGES, even STL for laser scan models when we're talking about model formats, in addition to the proprietary formats as well. So it's able to bring in your CATIA files, JT files, NX files, 3D XML files into the system for your model geometry. For the meta information itself, you're able to utilize information from spreadsheets, XML documents, things like that, in a non-proprietary way.
Awesome. Okay. Well, we're going to wrap it up here. So thank you, Uriah and Joe, for presenting this. We really appreciate that.